I thought it'd be really fun, and I was hoping to do this before we even started, to just show you some fun things you can do with pure data, and then we'll talk about what it is and how to use it. So you can see some code up there, and all I did was I just recorded some video, and I can scratch through the video. So this is kind of a fun little. This is Good, that looks good right there. So this is just a kind of a fun demo thing. So I can set that as my beginning, and then set an end, and I'm gonna find out the audio samples for that. And then I'm gonna set it so that that triggers with the S key. And I already have the A key.
Yes, yes, yeah. Yes.
So it's fun things you can do. Like, and I already have that set up to work with these this very fancy musical instrument.
Yes.
So it's really it's a very good tool for doing those kinds of real-time manipulations. And you can see that actually the latency is pretty good. And if you even look at my we can watch my CPU load on this like really high-end Chromebook. Yeah, and most of it's going to the Google Hangout.
Yeah.
It really isn't much load, so it's very efficient. Okay, so now that I did that and probably confused you with what PD is, let's talk about what it is. So it's yeah.
Can we get that link so we can send it out to everybody?
Here's my email for everybody who wants to see it. It's here, right?
Whenever if you go back to this part, there should be a link on here.
See, the problem is I did it all with the
links. Like, oh, there was click links, and then I just need like that.
Okay.
You could send that to me in
as an
any way.
email.
Email, or just send me a Hangout message.
I don't know your email actually.
Well, I think I'm on here. In your Hangouts? No.
Oh, I am? I don't
know.
think so.
Okay, well then yeah, go back to them, I guess.
Here, let's do this. Yeah, you're not there. Dom's there.
Oh.
I
guess just send it to Dom and I'll figure it out.
Okay. Where were we? So here are my notes. So you can watch along. So what PD is it's called a patching language or a data flow language. And the guy who wrote it, Miller Puckett, is actually kind of invented that idea. And the idea is, it's not a procedural language. You don't write code in sort of a one dimension the way we're used to. It's not an object-oriented language where you create classes or anything like that. It's a visual language. It's a visual language in 2 dimensions where you connect objects and make relationships between the objects. So this is directly modeled off of the old analog synthesizers. So, each of these things is an object, right? This is some synthesizer of some sort, and it's connected to another object, and that's how all the relationships work. So the way you can think about this is, the old school modular stereos, for example, right? Like, that's how those worked, right? You had a record player, and then the record player had data that came out. That was the audio, right? And that plugged into a receiver, and the receiver changed the audio. And how did it know how to change the audio? I mean, there's stuff inside of it. That's the object. I don't know why that's clicking. But also there were some other things on the receiver, right? What? Knobs, thank you. So knobs are messages in PD. We have objects and we have messages. And finally, from the receiver, it went to the speakers, right? And so each thing in the system modified the audio in some way, which was your data. So PD follows that model exactly. Now, that's a dangerous model to follow, right? Because pretty quickly you can end up with that. So, the way I want to do this presentation is, as you guys have questions or whatever, just interrupt me. If there's something I haven't addressed, let me know. But this is something that I really want to address because it's a danger in PD, and I can show you ways to handle that issue. But anyway, so going back, and just talking about PD a little bit, PD was written by a guy named Miller Smith Puckett. And before he wrote PD, he wrote a commercial version of it called Max MSP. Max stands for Max Matthews. He kind of was the great granddaddy of electronic music synthesis. Really the guy who pioneered it all. Back at Bell Labs in the 50s, he was making sine waves sound like something. It was blowing people away. So Miller named it after Max Matthews. The MSP is Miller Smith Puckett. So if you thought I was lying that Miller Puckett wrote Max MSP, I definitely was not. That's a commercial program. It's much more popular than PD. It looks a lot like PD. It's about $750 if you buy all of the features. So he made his money and decided that he would go into the less lucrative academic world. So he's now at UCSD. And then for his research, he rewrote Max MSP and called it PD. So that's what PD is. So it's open source, cross-platform. Unlike Max, it runs on Linux, which is nice. And just to, as you're exploring this, immediately, the first choice you have to make is, do I want, let's see, I'll do this. Do I want PD extended or PD or pure data, which is often called PD vanilla? So just so that you're clear on the difference there, Miller Puckett writes PD vanilla, and he pretty much writes it on his own. He takes advice from other people and sometimes doesn't take advice from other people. And it's only audio. It's strictly audio. People saw this and they thought, wow, this is really cool. I want to add things to it. So people added video, they added matrix, multiplication, and a whole matrix library. They added physical modeling. So all those things, people just kept adding different modules, and it got really confusing, because people come and go to an open source community. Some modules didn't work anymore. Some people didn't, So what they did was they grouped the most popular working modules together, and they called that PD extended. So that's what PD extended is. There's a third option too that this kind of group might want to know about, which is PD Linux Laptop Orchestra, which is actually probably the most actively developed version of PD right now. I think you want the Burrito Supreme version of it. The problem with it, and the reason I don't use it that much, is that I teach PD a lot, and it only works in Linux. So anyway, so that's kind of an overview of the options for PD. So we're going to use PD extended today. Now what PD does is, one of the things, besides it being a patching language, one of the things it does is it models this idea of an instrument. And so, I'm a violinist, and I perform on the violin, but I don't make violins. So there's the instrument maker, and then there's the instrument performer. And one of the things that I think is really cool about PD is it actually combines the idea that somebody can make an instrument and perform with it. And they can make a part, and then they can try it. And they can change this and then try it again and switch back and forth really quickly. And so the way PD deals with that is it has what's called performance mode and edit mode. And so you can switch between them really quickly. And you'll see in a minute how that works. So let's just play around with PD a little bit, make some really basic things together. So I'm going to close all this. We had our fun. When you open it, this is what it looks like. I'm going to create a new, what they call patch. And you can see I just get a blank window. So this is actually a philosophical choice that Miller Puckett made. The idea is that you can explore anything. And so if you have icons, that automatically already brings you to thinking certain ways, like, oh, there's this icon. Okay, I guess the idea is that it's just a completely open canvas. What you can do is you can put objects in. So these are some different objects. And for this presentation, I'm pretty much going to use, in order to save time, I'm going to use the shortcuts, the keyboard shortcuts, so Control-1 for an object. So just to get started with that right now, I'm going to Control-1. It creates this object. Now I have to say what kind of object I want. And I'm going to choose a cosine oscillator. And I'm going to choose 440. Why did I choose 440? It's actually A. It's the A tuning note. I just chose it for fun. So, so there's my object. I can move it around, you know. I don't hear it, right? It's like a stereo system not connected to any speakers. So the next object I'm going to need is some sort of speakers. Digital to analog converter. So that's what that is. You guys can see this all okay? I might just go with it if you can see it at all. Just sit, okay. So here I am making a patch cable and I connect it. This will probably be loud. It's pretty loud. Maybe it should be louder. Okay, that's good. I'm gonna break those. So, so now I've used PD a lot, so I know the names of objects, but what if you didn't? So one of the things to immediately know is you can right click and choose help. And that will give you a list of all the different objects that you could have. So I think maybe the first thing we might want to do is build a volume control for this. So I'm going to take my signal and I'm going to multiply it by some number. And I'm going to choose the number right here. So all this stuff is right. I'm using shortcuts, but you can see all those choices right here of, you know, I just chose the horizontal slider. So I'm going to connect the horizontal slider, and I'm going to connect, go back here, connect this. Now, what is the range of the slider? We don't really know, right? I actually do know, and I know that it's not what we want. So I'm going to break this and show you what it is. So I'm going to create a number. Now here's where the difference between edit and performance mode is important. So I'm in edit mode now, and I always am kind of noting whether, good job. So I'm always noting whether I'm in edit mode or performance mode by looking at the cursor. So if I look at the cursor, I have this, is that right? It's something like this, I don't know. It's kind of a known PD icon, this thing. So that means I'm in edit mode. Now, I'd like to move the slider, but I can't. It's like performing on my instrument. All I can do is move it around this way, but I can't slide it. So you can switch between them. It's Control E is your toggle. I'm going to do that. Now I'm in edit mode, I mean performance mode. And I can slide it instead of moving around. So it's from 0 to 127. A signal should be between 0 and 1. So I need to change the range of this. I can right-click it, choose properties, and change the range. I can also make it fun colors and things like that if I really care. And I could make it fat and big or something. I'll make it small just for fun. So, you know, so I just changed what it looked like. Now I can connect that. So I have a volume control. So one thing that's really nice about PD is that in this ability to go back and forth so quickly, you know, and building my objects and instantly being able to try them, I don't have any like waiting for compiling kind of things going on, which is really nice for workflow. And part of why I love using it so much, because I can just try something instantly. So I don't know if this bothers anybody else's musical ears, but can you hear how there's what they call zipper noise in this? So you hear this as I move the volume control. So there's a way to, there's an object to deal with that. Does this so far make sense about connecting the objects? And is this an object, by the way, this thing, the slider?
Yes.
It's more like a message, really, because it's sending a number here. It's like a knob, yeah. So so right now, when I'm moving that knob, I'm moving it like this, really quickly and jerkily, and so I need to smooth that out. And the object to do that is called line tilde. So what I can do is I can say change from one value to another. So so I could say change from 0 to 1 and take 100 milliseconds to do it. I'll just kind of show you what that does. So now I want to activate this, but I can't because I'm in edit mode. So I changed to performance mode. And it's changing really quickly. 100 milliseconds is pretty fast. Let me add a 0 there. You can see how it changes slowly now. So that's kind of what line does. Now, did anyone notice I had line tilde there first, and now I have line? So one of the differences, and I'm just trying to, I'm going really fast, so if there's things that are confusing or whatever, just stop me. But one of the things to know is that there's audio objects and there's control objects. So an audio object has a tilde on it, and a control object does not. So here's the thing: PD dates back to the 90s, and it references electronic music programming languages back to the 50s. So when you look at computers that were even from the 90s, calculating one number at a time, you had 44,100 cycles per second, like the audio is working, for CD quality audio like this, is pretty inefficient. So what it would do instead was calculate an entire buffer at a time. In PD's case, a buffer is 64 samples. So instead of calculating each number, it would calculate 64 at once, and then pass that on, so that each object is calculating 64 numbers, passing it on. The next one gets 64 numbers, passes it on. That's what an audio object does. A control object just does one number. Does that distinction make sense? So, so that's why there's two different types. Now, in my case, I want to make this as smooth as possible. So I want to feed an audio object into my multiplier, but I have a control object. It'll probably still sound okay. I don't know for sure. Let's see. Just loud, that's all. Let me lower that. So it still sounds okay, but what I'd really like is to have it be absolutely smooth. So I add the tilde there, and I think it's mad at me. And so that makes a very smooth transition. What I want to do really is take this number, whatever number is coming out of here, and change gradually to that new number. So what I want to do is, instead of having these hard-coded numbers here, I want to send a parameter. So $1 is the way I would refer to that parameter. If I had 2, I would use $1, $2. So I'm going to change to the new number, and I'm going to do it over, say, 100 milliseconds. I'm going to raise the volume of the speakers. So I got rid of that clicking noise. Make sense? What would happen if I made this 1,000 instead of 100? Yeah, exactly. Make sense? Okay, cool. So there's a couple of things that that we did. We did audio versus control objects, and we talked about interpolation, which is what the line object's doing. Any questions so far?
Why do some of the boxes only have like 2 little tabs on top and some of them have 3?
Because each object, just like your stereo has, your stereo has a whole bunch of connections, but maybe your 8-track tape player only has input and output. It's just like that. So each object is separate in that way, has a certain number. And one really good thing to know about is that you can right-click. You already saw I right-clicked on what they call a canvas, and I could get help for any object. But I can right-click on the object itself, and I get an interactive help patch that will show you exactly what it does and how it works and all that stuff. This is something that I'd actually like to talk about right now, which is that it has arrays, and that gives you a really easy way to graph things. So let's actually graph what we're seeing. So maybe I'll make a 1,000-point array, and we'll call it my great array. I don't know. And so there it is. I can see it. I can move it around, and then I can graph to it. Everybody see that? Okay, there it is. Look, I didn't see it either, and I made a mistake. Okay, so I can graph that. I wonder what it's mad about. Anyway, we're not really seeing it graph because we've never told it when to graph. And so this is another really important message that you see a lot in PD. And it's called bang. And what you have to do is tell something, do this now. And that's, or like, you could think of it as like sending it a trigger. It's like, now. And so I have to create an object to tell it that. This is what that looks like. It's just a little button. Now I'm going to bang that. I did something wrong. Oh, I know. There's no audio coming through. There it is. So if I wanted that to repeatedly get banged, I know this sets me up for so many jokes. I can create a metronome. So I'm going to show you, after I load the volume, what the metronome does. So it's Metro 1000. I have to start the metronome. What do you think it does? Huh? Sends repeated bangs. I can change the speed of it. Right. Aaron, just to be totally inefficient, I'm going to connect this bang to this bang. Right, so makes sense? So one nice, really nice thing about PD is that very quickly you can visualize what you're doing and the data that's going around. And that's something I really like about it. And I'm just going to mention, this is actually, besides the obvious reason that it's stupid to do that, it's much better to do something like, if I really wanted to get that visualization and see that happen, that's great. But this is not as good programming practice for PD as this, connecting directly. And part of the reason why is that PD is actually surprisingly inefficient in actually showing these visualizations. And so you can reach a point in your code where you have a lot going on and the majority of your CPU load is going toward debugging visualizations that are not helping you anymore. And it's really nice to be able to delete them without having to worry about the connections that you have accidentally destroyed in doing so. So just something to know. So let's build another audio thing, then we're going to go to video. Die. Okay.
Really quick question.
Yeah.
You're working with that cosine waves there. Can you do like square waves and sawtooth?
Yeah, they're not built in, but you can create them. Sawtooth is actually built in. It's called phasor tilde. But to do a square wave, you could do something like there's like a bunch of ways you could do a square wave. But one is that you can look at the value of the cosine or sine wave that you're sending, and if it's positive, send 1. If it's negative, send 0. I mean -1. So what I was thinking is at the end we can hang out, and I brought a bunch of demos, and we can talk about this stuff and build something like that if we wanted. So I want to build a little audio scratcher just to show you how that would work. So I'm going to make a 2-second audio buffer. So how many samples will that be? CD quality, huh? Yep, 88,200. My great audio buffer. Why? Okay, there it is. I'm gonna record to it. Speakers were digital to analog converters. So what do you think microphone is? Yeah, analog to digital converter. I'm gonna write to that. Have write tilde, my great audio buffer. What We'll just do the left channel. It's not recording. What do I have to do? What am I missing? What's that magical message? Huh? Bang. Yeah. So I create the bang. Migrate audio buffer. There it is. So, I mean, that's nice, right? It just immediately showed it to us. So let's play that back. Now, what I have to do is read each sample, right? Just like I basically have an array. I have to go through the entire index of the array and read it. So that's tab read for tilde. It just is. I don't want to get into the for. You can look it up on the help. There it is. And I have to tell it to read every sample. Now, what's the object that we saw goes between values? We connected the slider to something to smooth it out because we wanted not to go quickly to a value, but over time to go to a value. What was it? Line, yes. Yep, connected to its speakers. You guys already know that one. And so I'm going to go from 0 to what sample? Kevin knows, 88,200 over 2 seconds or 2,000 milliseconds.
You can mess with changing those numbers though, right?
What numbers?
Like the speed.
So ahead of me.
Migrate audio buffer. Migrate audio buffer.
So when I'm clicking on this, what I'm really doing is sending a bang. That's sending the bang message when I click on it.
Migrate audio buffer.
Well, you know, now that you said that, I don't even want to bother. So instead, what I'm going to do is scratch through it a little bit. So I can make a slider. And instead of the range of 0 to 127, I'm going to go to 88,200. And I'm going to say, remember, if I want that parameter, what do I type? $, yep. And I want the first parameter, or only parameter, go to that value over, say, 100 milliseconds. Because I can't literally say, play this sample, right? I can't literally say, play sample number 4,000, right? Because that's just a number. So I have to play a range of samples to be able to hear anything. So I'm saying, you know, play from wherever you are to the new number I gave you over 100 milliseconds. Fail. Why? I know why. Do you guys know why?
Should be connected to the line instead.
Oh man, you guys are so good. Already fun, right? I could even go farther, right? This is when I get carried away, but right. I'm going to connect it to this just because it's not doing anything. I have to send it a bang. Right. You know what's coming, right? Louder. Yeah. Maybe it's too fast. Okay, get the idea, right? Should we move on to video? You're like, please. Okay. I usually start with video, actually, when I show PD, but audio is actually more basic. Everything we've done so far is just in PD vanilla. For Linux people, you could actually install each of the things that you want. You could install PD vanilla and then install each thing that you wanted on top of it, probably in the repository of your choice. So, with video, one of the things is PD is really two things. There's a synthesis language, audio synthesis language, and then there's the interface to the language. And so what happened, so what you're seeing here is the interface, right? But it's making a graph, a visual graph we can see, but it's sending a graph to the audio language, and the audio language then interprets what's happening, right? Does that make sense? If you install this on Windows, you'll literally see this happen because they talk to each other through sockets. And so if you have a firewall set up, it's going to ask you for permission for half a PD to talk to the other half a PD through the socket. So the reason I'm telling you this now is that what's happened is that when people expand to offer things like video, what really attracted them to PD was the interface more than the audio engine, right? I mean, they're doing video. They don't even care about the audio engine. So they didn't feel a need to follow all the rules that that Miller Puckett had already put in place. And especially with things like trying to make basically a wrapper to OpenGL, it was pretty hard to follow those rules anyway. So I just kind of wanted to warn you about that. I'm not going to get into too much about it now because I don't have time. But just know that some things that, as you use PD, you think make sense could break when you start messing with audio. So for audio, we need to actually start a rendering chain. So this is our rendering chain. All I'm planning to do is make something that projects my beautiful face onto the screen, because I know that you can't see enough of me now. So, so I start my rendering chain. Now I create a projector. And just to remind you, each of these things has help to show you how they work. If I wanted to remember what this was, there's also comments, by the way. Just like every language has comments, this is projector, right? And you can make your comments big and red and font 57 if you want. It has all those features too. So I'm going to texture that video onto something. This is not a projector. This is the webcam. The texture you could think of as the projector. And then we need a screen. Nice little rectangle. Now, this is one of the ways that this video library, which is actually called GEM, it's actually called GEM, Graphical Environment for Multimedia, but I call it GEM just like everyone else. This is one of the places where it breaks the rules, right? Because we don't see anything, because we haven't created a window yet. You don't have to do things like that in the audio world, but we have to create a window for it to show. So here's my window object. I got to send it a message. I'm going to tell it to create, and I'm going to tell it to render. So the one is rendering, the create is creating. There it is. Actually, I'd rather look at you guys. So I'm going to send a 1. I have to say device 1. It's a message, just like a knob. So that's this camera. There you are. No, maybe it was better when it showed me. Anyway, that's kind of boring though, right? We could instead project onto a cube. Right? That's kind of the inside of a cube or a sphere. It's kind of an ugly sphere. Let's add more points to it. So this is the number of points to my sphere, right? Then I could change the size of that sphere. So I'm shift dragging right now in order to change numbers in a number box. If I don't shift drag, if I just drag, the numbers change a lot bigger. So shift dragging is a way to change the numbers more gradually. And you can probably guess I could automate all this, right? So we could, I'm already running out of time, but we could, connect a line and do all that. But I kind of want to show you a different technique. Maybe instead of making this get bigger, I thought we'd just make it get bigger. Bigger, this is bigger. So instead of that, I thought maybe we could make it oscillate with a cosine wave. So we could take the cosine wave that we already have in the audio world, and have it change the size of the sphere in the video world. And I thought I'd show you a little bit about how to do that. It'll illustrate a little bit about this buffer, this 64 samples in the buffer as well. So I'm going to create my cosine wave. Oh, let's see. There is no sine wave automated generator. You can create a sine wave. It's not that hard. But anyway, that's life. I'm going to make it really slow. So it's got a period of 2 here. And, you know, wouldn't it be nice if I could, I'll take that and multiply it by something, say 3. Now, wouldn't it be nice, and you would expect this to work, right, if I just did that? But it won't let me do that. Why won't it let me do that? Do you see, actually, so this is audio, and this is control. I can't connect audio directly to control. And PD is trying to warn me. It's trying to help me distinguish. Do you see how this line is thicker than these lines? That's because, what?
Now that you mention it.
So, and do you see how this is hard to see from where you guys are, but this one's filled in and this one is not? Those inlets? This is filled in saying, I'm expecting audio. This is not filled in saying, I don't expect audio, I expect control connected there. The output is also filled in. It's saying, I'm sending audio. We have to convert that audio into control. There's an object to do that. It's called snapshot. So basically what it does is takes a snapshot of whatever's coming out of there when you tell it to. And even though I told you this is bad programming practice for demoing, it's just faster. So, okay, fine, I won't do it. I'll do it this way. So I said when you tell it to. How do you think I'm going to tell it to? You guys are good. Right, so I could do this. Right, and maybe I don't want to sit here and do that all day. So I'm going to say Metro. Anybody know where I got that number? 60 frames per second, right? So if I wanted this to be updated at 60 times a second, which is a good frame rate for this kind of stuff, that would be the number I'd choose. This is actually not running at 60 frames per second. It defaults to 20 frames per second. And that's, again, because of the age of the program. Because back in 1990, whatever, 20 frames per second was pretty good for a laptop. But now we can do 60, so I'm going to change this, put 60 there. And you can see it's a little smoother.
Is there a reason for the comma between create and more?
Yeah, it's actually two. Okay, yeah, it's actually 2 messages here.
Oh,
So I separated them that way. So
you're sending it in array almost?
I'm sending create and then instantly sending one. I mean, this is the equivalent of this. And actually, this gets to one other thing I want to say. We started late, but when do I need to stop? Just keep going. Okay.
I got all night.
Me too. So here, I'm just going to destroy. Okay, so I can create it, but it's not rendering. So I've created a window, but the window is not alive. It's not getting any power. I don't know how you want to think about it. I can send it a 1 to start it. I could send it a 0, stop it again. So I just sent those things back to back. And this actually gets to something else I want to talk about. Let's build something that multiplies 2 numbers. What multiplies by 2, right? So here are my 2 numbers. First, let's just make something that, you know what? I'm not even going to tell you what I'm making. Okay. So as I move this number around, this one says 54. This says 57. What's going on? No big secrets here, right? Yeah. So the +3, we call the 3 a creation argument. What about when I move this one? Whoa, it ain't doing nothing. Okay, I'll leave it there. Now if I move this one, so what's going on?
Overriding your creation argument.
Right, I overrode the creation argument, right, with the one on the right inlet. But the right one doesn't change the output. The output doesn't, there's no output that's given, and yet there's an internal change that happens, right? But you can't see that until then. There's a couple of ways that we could deal with that if we wanted it to output even from the right. But before I even get there, now that we know that, I'm going to build something. Here, I'm going to take out the creation argument just to make this really, really basic. Like really clear what's going on. I'm going to take this and I'm going to copy it. Control-C, Control-V, yep, just what you're used to. I'm going to take this number and I'm going to, looks like I'm going to double it, right?
Yes.
Well, let's find out. Make sense? Setting the number to itself? All right, let me just make another one then. We're on a streak. Whoa, they're different. The numbers are different. What's going on? Anybody have a guess? Dom knows.
Is he stapled? Does it remember where you were at in the first cell before you started moving the, because you were moving the first cell and the second cell started moving it. It's kind of hard to see the numbers from here.
Is it? Okay, wait, how can I make this bigger?
It's off by one. It's off by one. Okay.
It's off by 1. So let's go to easy numbers here. So it's off by 1, it's 1 less than it should be, right? As I go up. And it's 1 higher than it should be as I go down. Hint. So PD, like that number doesn't get sent, both copies of that number don't get sent to the object at the same time. One gets sent before the other one. So there's where the catch is, right? So if I go from 15 to 16, and I send 16 here first, and then I send it there, I'm going to get 32. But if I send, this thing already had 15 in it. If it sends here first, it's going to output 31, and then it's going to store a 16 in there. You see what I mean? So the order in which it sends those things is really important. In this code, can you tell the order in which it sends anything? No. So this is terrible. Never do this. Like this is like PD no-no. If you see this, like, because there's no way to know what's going on. So there's an object to handle this problem. And it's called trigger, and you'll use it all the time if you use PD. So I could spell it out, trigger, but it's so common and so often used that we can just abbreviate it with T. So I can say trigger, float, float, because these are 2 float numbers. PD doesn't really have integer. I mean, it does, but it doesn't for this object. So now what it does is it outputs from right to left these 2 outputs. Now, if I said float, 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 can you see how there's 3 of those now down there? Float, 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 float. Okay, should I do 5? All right, you guys got it? So it outputs from right to left. You might have guessed that it would do left to right, but if you think about how these inlets work, the right to left prevents you from having to cross cables all the time. So this is the way to create that. So that's kind of an important concept to know. The left inlet by PD convention is almost always called the hot inlet. I mean, it's almost always a hot inlet. And the right one, and all the right ones that follow after are cold inlets. So the difference is the hot inlet outputs, and the cold inlets only change the internal state of the object, but they don't output. Make sense? So just to show you really quickly, if I wanted to, going back to that adder that we made, now that I know about the trigger object doesn't just control the order in which things are output. You can also use it to change the data type of an object. So in this case, well, before I even show you that, let's go back to this issue. If I wanted to force this thing to output, I can send it a bang. So if every time this updated, I sent a bang afterwards, it would do what I wanted. It would always output when I change this. So I can do that. I can say trigger, bang, float. Trigger, bang, float. Happens a lot. So I connect this. So it first sends the float, and then it'll send a bang to the left inlet. Make sense? And so now I can get that output. Okay, so that's hot and cold. Now I wanted to show you guys really quickly. We've done really simple examples, but I think you can imagine already that you're going to run into a problem when you try to make something more complex, because you're going to run out of screen real estate. And also, you don't have a good way to sort of modularize your thinking. So there's 3 things I want to show you about that really quick. One, there's something called subpatches. So what a subpatch is, I can say PD for my object, and then my great subpatch. Well, that's good enough. And so there it is. So it's a new window, and I can create inlets and outlets on it. So here, I'll make something that adds 2 numbers. Just really quickly. So if I close this now, that has 2 inlets and 1 outlet, just like I made. So that gives you a way to sort of modularize stuff.
The location of the inlets and outlets on the object in the main patch, does it just mimic the structure of the subpatch?
Yeah, so you're wondering, how does it know which inlet is which?
Right.
Yeah, it does it left to right. So
Okay.
since this is the left one, in fact, watch this. If I take this one and I move it to the right, PD knows something happened and it crossed these.
Across the stream.
Never cross the stream.
I wonder if you can do that. Yeah, look at that. Woo. Okay. So that's great and that's nice, but that's not a way that you'd want to build like multiple instances of the same thing, for example, right? Because I can take this and I can copy it, and that's great. But if I change this one, that one doesn't change. So what you can also do is create what they call abstractions. And what that is here, let's just take that same code, just to save time. Copy. And I'm going to save this below. So now I just created a new object, and I can just use it, hello. Right, so then I could edit that object and change it, and it'll take creation arguments and all that stuff, and I don't think we have time to go through that. You also get instance numbers for those, and so that's a way that you can kind of create your code. The last thing I wanted to show you is that you don't have to have cables that connect your things. So this, for example, it has a send symbol and a receive symbol. So I can send it something, like I can say, I don't know. No, I would want to receive that. So now, was it this thing I was editing? I don't even remember. Okay. So now I'm just using what's handy, right? So I could say send Fred. And you can see the other one changing. So, and there's also a receive object as well. So I could, connect that here. So you can also clean up a lot of your stuff or create an interface for somebody to use without having any cables at all, any visual cables at all. A couple other things to know. You can, this is an open source language, and you can, the ways to create objects in C is well documented. So you can create all of your own objects if you want to. I've never done it, but I can tell you that it's well documented, and there's like tutorials to walk you through. So if it was something that you wanted that didn't already exist in PD and you didn't want to create it using the PD objects, you have that option. And that's how all these libraries were created too. PD is single-threaded, which is not great nowadays with our multi-core processors, but there's multiple ways around that. One that I use a lot is to create different instances of PD. Each one will end up running in its own thread. Your operating system is going to handle putting the load on the right core and all that stuff, so you don't have to worry about that. And then you just have them communicate with sockets. It works really well. So like, for example, I did a project where we had 3 webcams, some audio and some video, and I put each of those things in a different PD instance. So the image processing happening for the webcams didn't tie down that single thread. So there's also an object called PD tilde that's creates a PD instance within your PD patch that does the same thing. It came more recently, and I had trouble with it, so I don't use it. One thing that's in active development now is, your graphics card is really good at manipulating data and manipulating it in parallel. So there's something called PD CUDA, which is using the NVIDIA, what is it, language called CUDA? So it's they're expanding PD to be able to take advantage of some of that manipulation that's already on your graphics card. As I mentioned, PD is really 2 programs. So you get the interface and the sound synthesis. And so what people have done is tried to separate them a little bit more clearly. And the sound one is now totally independent, can be run independently. And it's called libpd. And with libpd, libpd runs on mobile platforms. So that's really nice. So you can do all this audio manipulation on iOS or Android if you want. Another use of PD that's coming up a lot is to use it on the Raspberry Pi, especially for audio. It's very efficient. And so people will build effects boxes, generic effects boxes, and then create their own effects. There's some video examples of that. So I should probably start wrapping it up, I'm imagining. So there's a lot of demos and things I can show you. Another thing is that there's a lot of places to go on. Here are some resources for you. Miller Puckett keeps his own resources that are really nice. He has a book that goes over a bunch of audio synthesis techniques and shows all the examples in PD. So that's a very nice place to go. The email list is actually very friendly and very helpful. And there's a forum. There's this weird PD ring where people show projects that they've done dating back to I don't know when. We also have the Wichita Patchers Circle, which hasn't gotten a lot of activity lately, but it's a place where there's a couple of us in town that use PD a lot and know it pretty well, and then there's some people trying to learn, and it's a place where we have a mailing list, an email list, Google group, and we have occasionally get together and help each other to try to build this stuff. So, and as part of that, I sort of built this page that you can take a look at that has a whole bunch of different examples of things that you can do. It has these really fun audio examples, video examples, pitch shifting, some cool things that have been built in PD by modesty forbids, I can't even say, So, so that kind of thing is a place to look for going on with this. But really, the most fun for me is if you talk to me, because I love this stuff. And for me, it's just really fun to build stuff in PD and really fun to help people to get going with it. So I also wanted to just address that there are alternatives to PD. I made a list of them right here. Processing is a really popular language. that's definitely an option that does a lot of similar things. It's much more focused on video than audio. If you want to spend some money, you can get Max MSP. It's a lot prettier. It has features like Zoom. So that's cool to hear. I guess that would have been cool today, right? So C Sound is probably, it's the one I started with. It's the oldest that's still used. It looks like assembler. It's crazy. And Open Frameworks is probably the most nerdy approach you could take. It's like C++ libraries that all tie together. It's very fast, and it runs well on mobile platforms too, and it's got a really good developer community. So that's an option too. So that's pretty much what I had. Does anybody have any questions or? Yeah.
Could you show us, just demo the video processing with like a color checker demo? Because I think that's one of the coolest features, and we really didn't get a taste for like some of the video processing stuff.
Right. Okay. Sure. So this was actually a color tracker. Where's the camera? Okay. So this actually runs best in 2 instances. So I just ran an instance to sort of demo it, and then the color tracker itself is right here. This is a patch I made. Where you can sort of say, I want to track red, green, or blue. So we can kind of see what it's tracking. Let's just have it. This is all the red that it's seeing right now. So the lights are good, I think. So I'm going to tell it, I want you to see, filter, you have to see less green than this, and and less blue than this, and more red than this. So let's get something red. Here, does somebody want to hold this or something?
Green one on.
Okay, there you go. Let me shut off the, so you can see it's starting to see it. Let me, I'm shutting off the blue and the green. Okay, so.
Red,
That's weird, it's not really seeing. Here, can I see you? There, it's seeing you.
Maybe if you view it behind the light.
So you can see it kind of moving that. Do you see it moving that dot? Right. And then these squares, you can create more of them and create numbers for them and stuff. You can literally drag them.
red 4 on.
So now move out of there.
Red 4 off. Red 4 on. Red 4 off.
We could record something more interesting,
Red 4 off.
But yeah, but you get the idea. So let's see, there's the webcam. This actually looks all right. There's an area in here that does not look okay. I forget where it is. But does that kind of give you an idea? I created this actually for high school students, so they could go in here and you can delete the boxes. So this will delete one of them. I don't know which one. Or deleted that one, right? And then I could create a new one. I created a new green box, right? I changed it to red. I could.
You did, it's just on top of the green.
Yeah, that's weird. I think I have 2 on top of each other. That's the deal. So I'm dragging both of them. So there. It's blue. Okay. Oh, yeah, there we go. Red, green, blue. How big I want it. Stuff like that. What ID I want to give it. 1, 2, 3. And then, choose different things that would get triggered based on that. So does that kind of answer your question? Maybe it was in here. I don't remember. There's something really ugly in here somewhere, but I don't know why I'm trying to show you guys. Any other questions? coolest thing you made of this? The coolest thing? I think it's I made a touch ball like a year and a half ago that used physical modeling and made sound. I can show a video of it after this if people want to see it. It's not something I can just set up and show you right now, but
I want to go ahead and thank John for giving us what was one of the most unique presentations that we've had for sure. It was definitely very interesting. Thank you.
cool. Thanks.
Stick around for just a second. I want to just go over our announcements real quick, and then feel free to come up here and ask John questions about whatever. Get Firefox or something going here.
Yeah, it's in a different window. Well, that works.
All right. Okay, we normally do this at the beginning. Things got a little out of order today, but that's all right. So I'll go quick. So anyway, for those of you that have never been to a DevICT meeting before, I'm glad you could come and join us. This is a program ran by MakeICT members. MakeICT.org is a great site on information on that. I'd encourage you to get involved in DevICT. And the best way to do that is to get on our Slack team and come chat with us. We're on there every day. Just ask myself or Seth or a couple of people who give you an invite. On our website, devict.org, you can see past presentations, including this one, including myself right now, because we didn't stop recording. For upcoming events, oh wait, I guess there's other ways to get involved. Donations, you could, if anybody has anything that they want to give a talk about, it's a great way to actually learn more about a topic, because you have to commit to it and then force yourself to learn on it. Jobs@devict.org, great place to post a job or look for jobs. For upcoming events, Women Who Code has events on March 9th, 14th, and 30th. On the 9th, Lynn Miskell's giving a presentation on some projects that she's working on. And then on the 14th and 30th are study groups. We have Code and Coffee every Thursday morning at 7 a.m. here. It's a little early, but you don't have to get here right at 7. You don't have to leave at any particular time. It's like an open house. Come hang out, work on some code before you go about your normal day. We also do nerd beers, which is like Code and Coffee, but it's at night, and it's with beer or not. Bring your own if you want. That's not weekly. That's monthly on the second Tuesday here at the Labor Party from 6 to 9. And this was the most important thing I wanted to point out was that tomorrow we're having lunch at Little Saigon over here downtown on Broadway, 1015 North Broadway. That'll be at 11:30. It's an open invitation to anybody that's interested. So we'll be there. Just come in and look for a familiar face. A group of us are going out to Lawrence towards the end of March for the Kansas Linux Fest. It's a free conference. I think it's free. Donations are appreciated. So we'll put an event on Meetup to announce that officially. It's not a DevICT event. We're just going. But we'll be carpooling. So if you're at all interested, please respond to on Meetup, and we'll try to organize probably a couple of cars to go out. Next month, myself and Matthew Keeler will be giving a double-header presentation on Vim and Emacs. So that'll be fun. And then tonight's event, you already saw. So enjoy. All right. You don't have to leave. Feel free to stick around. We'll be here for a while. And thank you again, John.
Yes, sir.
How do I stop the recording?
The red button.